welcome to the Crazy Hat Chemist. So another video in bonding and molecular structure. Bam! Today we're doing the resonance structures for a thiocyanate ion. I want you to try to get the thiocyanate ion from memorization that you should have memorized this one already before. It's one of the very important ones. It's SCN-1. Did you get it? Did you get it right? Okay, now what I want you to do is I want you to look at your periodic table and I want you to get the Lewis dot structure for the thiocyanate ion. I want you to come up with 3 different Lewis dot structures. Okay, pause that video, restart it, here we go, bam! Okay, here's one of them. There's a triple bond between a carbon and a nitrogen and then a single bond with that sulfur and the carbon. Notice that the sulfur, the carbon, and the nitrogen in the thiocyanate ion, why do we draw it as SCN? It's because that's the order of the atoms, and we're going to keep that same order of those atoms. Here's another different Lewis dot structure. Here's another different Lewis dot structure. So ask yourself, are all these following the octet rule? They most certainly are. Notice that they have brackets and the -1 charge on all of them. There's double-headed arrows in between each of them as well. It doesn't matter which one of these structures you look at, but you will get the same answer for this, and that is AX2. That is 2 bonding, 0 non-bonding. That corresponds to a linear-like structure. That's 180 bond angle degrees. Okay, and this molecule is polar because it has polar bonds and it is most certainly asymmetrical. It doesn't matter which one of these we look at. Also, notice that this has a -1 charge and therefore it's going to be polar also. So it's polar because it has a negative charge and it's polar because it's asymmetrical. Okay, all right. Now, the bond order. It doesn't matter which of these resonance structures we look at, but the bond order is going to be the same. There are 4 bonds and there are 2 bonding regions. That leads to a bond order of 2. Think about that. That's a very important number there for this problem. Okay, how do we distinguish between non-equivalent resonance structures? Formal charge. That's why I'm wearing my button-down shirt today. Yeah. All right, so formal charge is the valence electrons minus 1/2 the bonding electrons minus the lone electrons on that atom. So we're going to calculate the formal charge for each one of these here. So formal charge on that left-hand molecule, the left-hand sulfur, is -1. Now, sulfur is electronegative, so a -1 formal charge, that's really not so bad. Formal charge on the carbon, that's 0. That's pretty good, okay? And then formal charge on that nitrogen is a 0. That's okay. Formal charge on the middle molecule of the sulfur is 0, the carbon is 0, the nitrogen is -1. And then on the right-hand molecule, the formal charge of +1 on sulfur. Not so good, I betcha. Then the carbon is a 0, the nitrogen is a -2. Okay, I want you to notice something, that if you add up all the formal charges, they equal to the formal charge on the ion. You're going to notice that this is the case for every single ion or atom that you do. Look at the ones on the previous Lewis dot structures and the previous resonance structure videos, like carbon dioxide. They all added up to 0. Why? Carbon dioxide didn't have a charge. Okay, if you have a -2 charge on the ion, then the formal charges will add up to -2. Unbelievable. Okay, so the real question is, which of these 3 structures are the predominant? Is the predominant one? Or is there a combination or 2 that share, for example? So the question is, does all of them have an octet? The answer is yes. So check. That is the first one that we need to answer. The second one is, the formal charge that is most negative needs to be on the most electronegative element. Okay, now I want you to look at your periodic table and determine what is the most electronegative element, sulfur, carbon, or nitrogen. And it is, bing, 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 nitrogen is the most electronegative element of all of these. In fact, carbon and sulfur have the same electronegativity value of 2.5, and nitrogen has a value of 3.0. So nitrogen is more electronegative than carbon or sulfur. Carbon and sulfur have the same electronegativity value. Therefore, which one has the most negative formal charge on the most electronegative element? That would be, yes, that is correct, that central one. And that central one is letting you know that is the predominant Lewis dot structure of all of the resonance structures with the octet rule that's holding true. Super cool. Okay, I got another crazy hair thing going on here for you today. I guess it's a roll that I'm on. Okay, it's a thing, if you will. Give me a thumbs up if you like that video. Subscribe to my YouTube channel and give me a thumbs up if you like this hair. Okay. What did you like better? Did you like the green hair on the previous video, or did you like the pink and black hair? I don't know. Okay, give me a thumbs up if you like the hair, and don't give me a thumbs down if you didn't like the hair. But subscribe to my YouTube channel and pass it on to all your cool chemistry friends. Yeah, baby.